This is 5.2, systems of equations in several variables. So last lesson we learned and reviewed how to solve a system of equations with only 2 variables. Now we're going to extend that to 3 variables, or even you can go even further, 4 variables, 5 variables. And so we're going to look at that. So here's 3 different equations, and notice I have the black equation, the blue equation, and the red equation. So this first one's kind of a simple one, just because of the third equation is literally just z equals 3. So it's just a practice. What we're going to be doing is it's called back substitution. So we're going to substitute one equation into the other and then solve it from there. So if z equals 3, so we're going to literally put z into this equation. So we have the blue equation, y plus 2z equals 5, and we're substituting in 3 right there. So that becomes y plus 6. So y equals -1. Now we know z, and now we know y. So all we have to do is take the first equation, take x minus 2y minus z equals 1, and we're going to substitute in z is 3, and y is -1, and then we're just going to solve for the x. So x plus 2 minus 3, x minus 1 equals 1, so x equals 2. So notice we solved for x, y, and z. All right, so let's look at another scenario, and this is what we would normally typically look at. So we have 3 unknowns, x, y, and z, and we have 3 equations. And just so you know, that's how we're always going to proceed. If you have 3 unknowns, like the last lesson, we had 2 unknowns, x and y, and we had 2 equations. So here we have 3 unknowns, we have to have 3 equations. If I extended it to 4 equations, then there would be 4 unknowns, like A, B, C, and D, or something like that. So here, what we're going to do is I want you to first notice, because the way to tackle this is to try to cancel out one of the variables. And just like the last one, once we solved for z on the last one, once we knew what z was, it was easy just to back substitute it in. And so what we're going to do is look at, so think of like the first equation and the second equation. So this is your first equation here. First equation, second equation, and third equation. And so what we're going to do is literally if you look at your first and second, and then look at your first and third, and then look at your second and your third, and try to think about which one is the easiest variable to cross out. And there's, some people may choose to do 1 and 2, some people may choose 1 and 3, or 2 and 3. You've got to decide which one's the easiest way to cross out. So what I would do is, I notice equation 1 and 2, the x's right there are by themselves. And so I think equation 1 and equation 2 would probably be easier to solve for because they're all by themselves. Now you could also argue like equation 1 and 2, they also have positive 2y and negative 2y, so those would be easy to cross out as well. So again, what you have to decide is what's the easiest variable to cross out, and then go from there. So I'm going to take equation 1 and I'm going to take equation 2, and I'm going to end up crossing out the x's. So notice I lined them up, and then what I'm going to end up doing is I'm going to subtract these equations, or if you want to think of it as multiply this whole equation by -1 and then add them, so whatever. So I'm going to, if I subtract them or multiply by -1 and add, so the x's will eliminate, and here I'm going to get -4y, and then plus 4z equals -12. And you could have also done the top equation. Maybe the top equation would have been a little bit better, so we'd have some positives here. But either way, you're going to end up solving. I eliminated the x's, and now I have one equation with just 2 variables. Now the plan of attack is to do the same thing and eliminate the x's again. And so we're going to do, here's my step 2. I'm going to choose 2 other equations, and then I'm going to eliminate the x's. And again, you could choose like equation 1 and 3, and that's, all right, so here's equation 1 and 3, and notice if I try to cross out the x's on this, I'm going to have to multiply this whole thing. I'm going to multiply this whole thing by -3 if I want to cross out the x's. So this new equation becomes -3x, the top equation, plus 6y minus 9z equals -3. And I'm not changing the second equation at all. So now if I add these columns, I'm going to end up getting 8y minus 14z equals 0. Now, the whole reason why I did this, and I want to emphasize again, there's multiple ways to attack this problem. So you can literally choose different equations and try to cross out x's, or maybe you wanted to cross out your y's, or maybe someone else wants to cross out the z's. So you have to decide to cross out one variable. And notice why I did that. I chose to cross out the x's, and what I have left over is that and that. And now what I notice, if I try to solve this, so I'm literally going to line the purple up. So if I put the purple right here, and now I'm going to solve a system of equations with only 2 variables. This is what we learned last lesson. So to do this, notice the y's would be very easy to cross out if I multiply this whole thing by 2. So if I multiplied the top equation, I'm not going to change it all. So here's the red. And then the purple, I multiplied by -2, so that or +2, so that becomes -8y plus 8z equals -24. And now if I add these, notice the y's will eliminate, and I'm going to end up with -5z equals -24, or z equals 24/5. Well, as soon as I said that, I noticed that I made a simple error. And I'm sure you noticed it as well. That's -6. And that's going to give me 4. All right, so once now I've solved for one variable, I'm practically done. All I'm going to do is back substitute in, just like example 1. And I'm going to literally take z equals 4, and I'm going to back substitute it in. So -4y plus 4 times 4, because z is 4. So -4y plus 16 equals -12. And then we have -4y equals -28, y equals 7. So now I know 2 of the variables, and then you just substitute that back into one of the original problems. It does not make a difference to find the x value, and you're going to end up getting x equals 3. So now I solved for all 3 variables, x, y, and z. All right, so let's look at one more example using it as a word problem. All right, so Fred has $50,000 to invest. He wants to invest it in a money market fund, which earns, on average, 5%, a blue chip fund, which earns 9% on average, and a high-tech fund earning 16% on average. He wants to earn $4,000 the first year. He also wants to avoid a lot of risk, so he invests 3 times as much in the money market compared to the high-tech fund. And again, if you're not aware of how to invest money, this may seem like, why would he, the tech fund, which earns 16%, why would he just invest all his money in there? Well, again, keep in mind, it's on average, and certain funds over time may average 16%, but in 1 year, it may not. So you don't want to put all your money into one fund because, that fund that particular year could actually have a negative, you could actually lose money or lose value in that 1 year. So again, on an average, over like a 10-year period, it may earn 16%. And so just keep that in mind. That's why, typically when you have an investment, into a mutual fund or retirement fund, it's called diversification. So you take your money and you diversify it into several different funds. So it's not all in one fund. And it's more risky if you do that. All right, so here what we're going to do is we're going to set this up. We're going to take literally do X, Y, and Z. We're going to set this up into 3 different variables. So this is the money market fund. The Y would be the blue chip fund, and the Z would be the high tech fund. All right, so just my X, Y, and Z, that's what they're going to represent. And notice what we know that we're going to invest a certain amount into each fund. So literally X plus Y plus Z equals $50,000. So again, I don't know how much we're investing. That's what we're trying to find. So I'm going to invest a certain amount into the X fund, into the Y fund, into the Z fund, and I know it will equal 50,000. I also know that the X fund, which is the money market fund, earns an average of 5%. So this literally would be 0.05x. The Y, which is the blue chip fund, earns 9%, and the high tech fund earns 16% interest, and I want to make $4,000. So that's my second equation that I'm going to invest in. And then notice the third equation comes from this last part. He also wants to avoid a lot of risk, so he invests 3 times as much money in the money market compared to the high tech fund. So this literally is X equals 3Z to be able to do that. So now we have our 3 equations, and then you can just literally start substituting back in and solving it to be able to do that. And once you do that, you're going to end up getting the 3 amounts. So once you solve it, you're going to end up getting the X, the money market fund. You're going to end up getting $30,000 is how much he is investing, and then the Y and then the Z, that's how much he invested in each account to be able to do that. And by the way, just one recommendation if you do take this as an example and you solve this, one suggestion is, just to get rid of those decimals, that would just multiply everything by 100 is what I'm going to do. So that would be 5x plus 9y plus 16z equals 400,000. So that's what I would do, is to get rid of those decimals. Okay, that's right off the bat. And then again, what I would do is back substitute in. So there's several ways some people might take this over and write x minus 3z equals 0 and might solve it that way. All I did is I took this and I substituted it in. I just replaced the x with 3z. And then notice I'm eliminating my x's then. And then I solve from there to eliminate my x's. So there's multiple ways to solve it, but we're using the elimination method to solve a system of equations with multiple variables.